Hello, hello, college algebra students. This is Mrs. Carlson, and this is college algebra, unit 3, review number 1. Let's get started. The first thing that we need to do is graph this piecewise function so we can go find values for it. So you need to have your graphing calculator. If you're watching this at home and you don't have your graphing calculator with you, then you're able to get the information here. So you're going to first start with a graph. And we need to go get a piecewise function, and there were 2 pieces to this piecewise function. And sometimes the smartboard doesn't work here, so I'm going over here, clicking the enter button, trying to really make this work. All right, so we're going to enter in x squared plus 1, and you can push tab, and then I have to say that when is that going to be, what are the restrictions? It's when x, and then here's my inequalities, is less than -1. You want to make sure to use that big negative. And then the next piecewise function is 6x subtract 7. And when is that restriction? It is for all x's that are greater than or equal to a -1. So -1 is where some stuff's happening. And I'm going to take this and smooth this out way over here. And there's my function. So I can see this is a little parabolic right in here. I can see that. And so I need to go get a table of values, and so all I'm going to do is Control T. And I have to get some negative values, so I just want to make sure that I go up. And so at -3, I have 10. At -2, I have 5. At -1, I have a -13, and at 0, I have a -7, and at 1, I have a -1. So I just want to make sure that you know how to get a piecewise function. So that's what we're doing for the first one. Okay? And so we have our values of 10, 5, -13, -7, and -1. All right, the next one, number 2, we have not done this one, but you're going to be able to do this. It says find the values of x for which f of x is equal to g of x. So this is the key thing that we need to know. Do we know what f of x is? Well, yeah, f of x is equal to x squared minus 2. And they're saying to equal it to g of x. And do I know what g of x is equal to? Well, yeah, g of x is equal to x plus 4. So can I solve this quadratic? Absolutely. I'm going to move my x and move my 4 over to the other side. So I have x squared minus x. And that's going to be, -x and a -4 here, -6 is equal to 0. So now can I solve that? Yes, I can. And how can I back that? What's going to go and multiply to give me -6 and add to give me -1? So I'm thinking about something that multiplies to give me a -6 and adds up to give me a -1. And I believe that would be the numbers -3 and 2. -3 and 2. So x minus 3, x minus 2, that's equal to 0. And then I'm going to solve, and I have little baby equations. And we know all the time that what we're really doing is just taking the opposite. And so that's what I get when I'm finding f of x is equal to g of x, right? I'm just setting the 2 functions equal to each other and solve. Over here, when we're talking about domain and range, I'm going to pause for a second and make a box so we have that box to look at. Okay, so here I have my limey green box, and I have an important point there labeled. You please label that onto your graph as well. And so I have my box, and domain are the x values. So I'm going across the x-axis and I look to see where does my graph begin at, and it begins at 3, and then where does it go to? Remember that this arrow is an arrowhead that goes on and on and on, and so it goes to infinity. Now I need to have some end marks. It is a bracket for 3. It's a bracket because that point right here is included in part of the graph. In infinity, it's always a parenthesis. For range, I'm going to do the same thing, except I'm going to go for the y values. And so here's my graph again, or my box again on top of my graph. And as I go now on the y-axis, there's my graph, and it begins. It begins at this point right here. And again, that y value is a 0. And where does it go to? It goes to infinity. The end mark on the range is a bracket. Again, this point is part of the graph, and you can see that it was labeled there, and it's a parenthesis for range. The parent function, you can have a couple of different things here. I don't mind. We talked about 2 things. F of x is equal to the square root of x is the parent function, or if you write square root, that would be acceptable. Okay? Over here on the next one, I'm asking you to graph the parent function. And so what you have is you have a grid here that you can graph it. And so I'm just going to put in some lines really quick. So I have a grid. And that's going to help me to label it. Let's move that over there a little bit. Right there, right on. And so identify the parent function. And so what is the parent function for this graph that we have? So it would be f of x is equal to x cubed, or you could have the word cubic. Either way, then you can have that. And then we want to graph it, and so let's graph what it looks like. It's going to be up 4, 1, 2, 3, 4 on this graph. 1, 2, 3, 4, and it's going to come down, and it's going to go up. So something like this. And so what kind of transformations are happening? Well, right away you can see with this one right here that it reflects over the x-axis and translates up 4, and it could be 4 units if you want to. But the key thing is that it translates up 4. That's what I really want. Remember, that's your k value here, and your k value is telling you if you're moving up or down. Number 5, determine the intervals over which the cubic function is increasing or decreasing. And do you know how to graph that cubic function for number 5? And so we just need to find what those points are. So let's identify these points on our graph. And so this one here, that's going to be an important point. It's a change in direction, and that's going to be 0, 2. And this point right here, that's going to be a positive 2, and then a negative 2. So we have those points identified. So now as I graph this, or as I follow this, and I'm going to follow it with a green pen, what direction is my green pen going? What am I doing? Well, I am increasing. I am going up. So I'm going to start with increasing. So where did I start at? Well, I started down here, and that's a sloppy arrowhead, and that's at negative infinity. And then where did I go to? Well, I went up here to this point right here. I went to this point right here, and that is at 0. Now, I hope that you hear me. Maybe this is the first time, but anytime we're dealing with any type of interval, Intervals are always x values. Okay? Always x values. So this goes to the 2. And I am not including any of those points. Now as I continue on from this point here, what am I doing? I have a change in direction and I am decreasing. So where am I starting from? I'm starting at 0, right where I left off. And where am I going to? What's the x value? I am going to 2. Again, parentheses will be my end marks. And then now do I have more to go? I'm changing direction. And where am I going? I am now going up again. I am increasing. So increasing has more. So since it has more, I'm going to say there's a union. And where does it start at? 2. And where does it go to? Infinity. And I put my parentheses here. And then for a constant, don't leave it blank, please. But there is none. You could also say not applicable if you want to. There is no constant this time. Okay? So now we're on number 6. And on number 6, it's telling you to graph that function there. And so using your graphing calculator to approximate 2 decimal accuracy. So I'm going to go and graph this. So we'll go to a graphing calculator. I'm going to go and add a page. And I'm going to add a graph. And here I'm going to graph number 6. And so I know that it's a cubic, x to the 3rd. I want to make sure I move my cursor down. Subtract 6x. And then I add 2. And now I graph it. And so I can't really see the top of this graph up here. So I'm going to change that. I'm going to change that to next. Okay? And then I'm going to change these really quick to -5. And changing this one over here to a 5. Okay, so I kind of spread that out a little bit. And here's my function. I'm going to move this over here now so it's out of the way. And I'm going to now find a minimum and a maximum. So menu, 6. I'm going to go find my maximum. My maximum, I want to make sure I am past my point. And so I click enter. And then now it says that I need to go upper bound. And so I swipe across it. As soon as I swipe across it, I push enter. And it even tells me, hey, there's your maximum. So now I'm going to go find the other one. I have minimum, analyze graph. I go to minimum, and I go past it. And I'm swiping, and I click enter, and I go past it. You can see now that I have to do that with the upper bound. And as soon as I passed it, I have the calculator identifies it and even tells you that it is a minimum. So jot that down, take a second to write it onto your graph. So finishing up on number 6, it's asking for the relative maxima. And so I'm getting to my right pages. And so copy that graph onto your paper, and then the relative maximum, you're going to write for the maximum is a -1.41 and 7.66. And then it asks for the minimum, and that's going to be a 1.41 and a -3.66. And so that's how you're going to do that one. And we've done that before. We've practiced that in class lots of different times. So for the next ones, 7, A, B, C, and D, you're going to graph all 4 of those. And so I'm going to go ahead and pause, and then you take a chance to graph them, and then I'll graph them too. And then we can talk about if they're even, odd, or neither. Okay, so for number 7, we have to tell if it's even, odd, or neither. And there is an algebraic way to determine that, but we haven't done it that way. We've always just graphed them. And so what I did is I took a minute and I paused everything so that we could graph them. And as we look at letter A, we have 2x to the 4th plus 3x squared, and that is even. You can see that I can take this and I can take it right down the middle and fold it on the y-axis, and it looks the same on both sides. So this first one is an equal. And so that's E. And then the next one, whoops, went the wrong way. Oh, there we go. There's the next one. 4x to the fifth minus 2x. And so this one is an odd. You could spread it out a little bit and change these dimensions if you wanted to, so that you can widen this up a little bit. And so there we go. And so you can see that I can do a double flip. I can take this and I can flip this over, and I'll do it here lightly in green. I can reflect that over the x-axis. And then I can again fold it on that y-axis right there, and it would be the same thing. So when I can do that double flip, it is odd. So I'll go on to the next one. And you can't see the graph on this one. And so one thing that you guys, I haven't taught you and shown you what to do is you can take your graph here and click and hold and just pull the graph down. And see how my grabber hand looks like it's picking like a pile of paper up there? And so you are able to do that. I still might want to change my dimensions, but if I go ahead and reflect this, is it going to be the exact same thing on the other side? And it's not. What happens is this reflects and it's not going to be able to be an even fold, and so this one is uneven. And then the last one, I've already grafted it again. You can't see it, and so I can bring this down. I can get my function out of the way a little bit. And this one, again, if I take it and I fold it right across that y-axis there, it's going to look exactly the same, and so that's going to be an even. And so that's number 7. So you got to graph each one so that you can see what those are going to be. All right, and then over here now I have to describe the transformation. So this is multiple choice. It's not multiple guess. And you can see that the only thing that I have changing this time is that -5 right there. And so you have to remember, is that a shift left and right, or is that an up and down? And I have a few students here, and what do you guys say it is? Up and down or left and right? Left, right. Left, right. Okay, they're all stars now. And so the other thing that you have to remember is when you do this, we know that it goes left or right, but we also have to take that and we have to solve it. And what we think most of the time is that it's just the opposite. And so that's x is equal to 5. So that's positive. And so what would that be? Is that going to be going to the right or going to the left? Right. Going to the right. Now, instead of saying left or right, we on this question, it's horizontal. Horizontal is left or right, and vertical is up and down. And so that's instead of, it's just a change in terminology. And so horizontal is going to the left, and in this case, we're going to the right. Or horizontal is left or right, and we're going to the right. So number 9, this one's another multiple choice question. And so the graph of this one it's a transform function of the parent function of x squared. And so we want to find the equation. We practiced this in class a few times. And so you want to go and identify an important point, which is this point. And this point is 1, 3. And so we know that this is the parent function. And so where are we going to have those shifting? So what's going to happen with that? So I know that I have f of x is equal to a x minus 2 quantity squared, excuse me, x minus h quantity squared plus k. And so I know that I have this important point of 1, 3. I know that the 1 is my h value. I want to take the opposite, so that's going to be a minus 1 quantity squared, and my 3 is my k value, and that is plus 3. I can't tell if I have any stretching or compressing. My answers don't really look like I do, and so I'm not going to worry about my coefficient. And so my new function is x minus 1 quantity squared plus 3. And what letter would that match? Matches letter Okay, moving on. So, same type of thing, just now I'm looking at different words and what's happening. So I have a parent function of f of x is equal to x to the third. So we know that's a cubic. And so we want to talk about different things. We know that the plus 1 is moving it which direction? Up, down, or left and right?
Up, down.
Up, down, and it's positive 1, so we know that that's up. And so up is vertical, left and, or up and down is vertical. So it's a vertical shift up 1. And so right away, what do we see? Vertical shift down, so that's no good. Vertical shift up, possibility. Vertical shift or horizontal shift 1, no. And then there's vertical shift up 1. Okay, so we've eliminated some choices. So no A and no C. And so now we know that we have this as a factor. And so I'm going to say bigger numbers are the stretch. Bigger numbers are stretch where smaller numbers are the compressed. And so the correct answer for this is letter D. Now I'll tell you, since we haven't practiced this enough, if students pick B, I'll accept it as okay just because we haven't talked enough about these words. We need to talk a little bit more about it. But the main thing I want you to know is that it's a vertical shift up 1. Number 11, we are again describing the transformations and what's happening. And so let's just start from the beginning. What's that doing? Reflect over x-axis. And what's that doing? Translate left, right, up, down. Going to the right, it's a negative, and so we know we need to take the positive, so it's going to be right 4. And what's that doing? Translate down. Okay, on number 12, we have lots of different parts for number 12. And so first thing what we're doing is we are adding two functions together. That's what this is saying. We are taking f function and g function and just adding them together. The f function is x squared minus 9, and adding it to the g function, which is 2x plus 9. And so you're looking to see, are there any like terms there, anything that you can combine? And you have x squared plus 2x, the negative 9 plus 9, they go away. So that's the first thing. So then the next thing is, what is the domain? So we know, we can go graph it on our calculator, but we know right away that this is going to be a parabola. And we know that the domain of a parabola is from negative infinity to infinity. That's it. And then now we're plugging in a negative 2. So I have x squared plus 2x. And so wherever there is an x, I am substituting in the negative 2. Negative 2 quantity squared plus 2 times 2. Negative 2 quantity squared is 4. 4 plus 4 is 8. Did I miss something here to this? Plus G. Plus G. Okay, I'm going to go back a second. So there's some question. I have this f plus g, and this is what my answer is for f of g, right? That guy. So I know that I have f of g again right here. But this time I'm going to substitute in a negative 2 wherever there is an x. So I see x, it's a negative 2, and then I square it. Plus 2 times x is a negative 2. So I substitute that in. Negative 2 quantity squared is 4. Negative 2 times a negative 2 is a negative 4. 4 minus 4 is 2. So now I'm going to do division. So I have the same thing, and I am doing division. So I have f, which is x squared minus 9, divided by g, which is 2x plus 9. So now I have to look at the domain. We know that this is irrational. We know that this has two parts, but we have to be careful of the fraction being undefined. So I'm going to take 2x plus 9 and set it equal to 0. And I get that x is equal to a negative 9 halves. And I'm going to say that x cannot be equal to a negative 9 halves because that would make a 0 in the denominator. And when we have 0 in the denominator, that's going to be undefined. And so what I have to know is when I'm looking at my domain, that the domain starts at negative infinity and it's going to go to a negative 9 halves. And there's going to be more to the graph because it is rational. It's going to pick up at a negative 9 halves and go to infinity. And now I'm going to substitute in my values at 10. So I'm looking at what is f divided by g. And this is what I got for f divided by g. So in fact, I'm just going to take that and I can clone it. And I can use it again right here. So that's what I solved for. So this time what I'm going to do, though, is substitute in 0 wherever there's an x. So I have 0 squared minus 9 divided by 2 times x, which is 0, plus 9. So I end up with 0 squared is 0, and 0 minus 9, that's a minus 9. 2 times 0 is 0. 0 plus 9, that's 9. So it's equal to a negative 1. Okay, moving on. Number 13. This is similar to what we did today, except you're showing that they're not equal to each other. And so we have to do our double substitution. So first thing I want you to do is rewrite this as f of g of x. And so we're going to take the g of x and we're substituting it. So here's g of x and we're substituting it into f of x. So I'm going to have f of x is equal to 1 over x squared, and I'm substituting in the square root of x squared plus 4 into my function. So I have 1 over x, and for x I'm now going to put in the square root of x squared plus 4, and then I am squaring. So the square and the square root cancel, and that gives me 1 over x squared plus 4. And that's all that I can do with that. I can't do anything else with that. So now I'm going the other way for this one. This one is g of f of x. So I'm starting with taking the f of x and subbing it into the g. So I know that g of x is equal to the square root of x squared plus 4. And so g of f of x is 1 over x squared. So I have a big radical. I have an x. I'm going to put in 1 over x squared, which is then squared, and then plus 4. So now, the only thing I can do right now is square the inside. So 1 squared is 1. X squared squared is x to the 4th plus 4. Is there anything that I can do to simplify that? So, are these two here equal to each other? Is this equal to this? No. So you would just say, well, 1 over x plus 4 is not equal to the big square root of 1 over x to the 4th plus 4. So this isn't difficult, but you have to practice it. You just have to practice kind of manipulating those functions together. So number 14, we're going to go graph 2x to the 3rd minus 1. And so I already went to go graph it. And here's our function, 2x to the 3rd minus 1. And you can see that at a negative 1 here, it moved down. And then 2 is a stretch factor, and so it kind of thinned it up a little bit. And so let's go and transfer it over here. And so right away, I would make an x and a y axis. And I know that my graph is that pretty straight. It's okay. I know that I went down 1, and I know that it kind of thinned up. And so I'm just Let me kind of do my little sketch like that. Okay? So, is f of x one-to-one? Is it one-to-one? Does it pass the horizontal and the vertical line test? Yes. So here's my vertical line, and that is not straight. There we go. And does it pass that vertical line test? Yes. Does it pass the horizontal line test? Yes, it does. So is the function one-to-one? Yes. And how do you know? It passes both the vertical and horizontal line test. So if it is one-to-one, find the inverse. And so I know that the function was f of x is equal to 2x to the third minus 1. So that's the original function. And so we know that f of x means what, guys? Y. Y is equal to 2x to the third minus 1. And so now I want to find the inverse. So I know that y becomes an x, and the x becomes a y. So now what do? Solve for y. Solving for y, I'm going to add 1 to this side and 1 to this side. So I have 2y to the third is equal to x plus 1. I'm dividing by 2, dividing by 2. So y to the third is equal to x plus 1 divided by 2. How am I going to get rid of that cube there? Cube root it. Cube root this side. Cube root this side. So y is equal to the cube root of x plus 1 divided by 2. Number 15, this is the one that we did in class today. This is what when we did that yellow foldable, this is it what we're doing, is we're showing that they're inverse functions. And so right away you want to have f of g of x. That's the same thing. So we're going to take the g function and plug it into the f function. So I have f of x is equal to the square root of 2x minus 3. I'm going to plug into this that f of g, which is x squared plus 3 divided by 2. So what's that going to look like? It's a big square root, 2, and then x squared plus 3 divided by 2 minus 3. This looks really familiar, like it's exactly like what we did. But it's good practice. So here, how can I simplify? 2's are going to go. It's okay that they can be reduced because they are being multiplied. And then I have a big square root of x squared plus 3 minus 3. And then what's going to go now? 3 minus 3, that's going to go. And then I have a square root of x squared. And then what happens? Square and square root go, and it's equal to x.
So would it be f of x equals x? Or
It's f of g of x is equal to x. But all you care about is x. Don't get worried about that. Just this is what you care about. All right, so now I'm doing the next one, and this is g of f of x. So you're starting with the f of x, and you're plugging that into the g. So what is g? G of x is x squared plus 3 divided by 2. We're taking and we're finding g of the square root. We're putting the f of x in there, 2x minus 3. So I have an x value. I'm going to sub in the square root of 2x minus 3. I have to square it, plus 3 divided by 2. So now what do you know? The square and the square root, those cancel out. They're inverse operations. So I have x minus 3 plus 3 divided by 2. 3 plus negative 3 plus 3, that becomes 0. Whoops, and I forgot my 2 there, sorry. So I end up with 2x divided by 2. What happens now? 2's cancel, and it leaves me with x. So now, what did you see? Is x and x, does that mean something? Well, yes, it does. The conclusion, that's what we practiced today. Anybody remember? So we'll say since, make it a little different, both functions are equal to x, this means they are inverses. All right, number 16. So what we have to do in this case is that we want to graph the inverse of this. And so let's go grab some points. So original, I want some x and y values. I don't need a whole bunch, but this one looks like it would be an important one that I might want to have. And what's that order pair there? 0, negative 3. And let's go pick this one right here. That one looks pretty good. 1, 2, 3, 4. 1, 2, 3, 4, 5. So I'm going to say 4, 5. The inverse, x and y. What happens for the inverse? They switch. X becomes y and y becomes x. And so that was a nice way how you guys said it. They just switch. So you're going to go plot those points. Negative 3, 0, 1, 2, 3, 0. And we have 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. And so it's a mirror. And so I'm going to go first of all and draw my mirror, my dotted line. I'll make pretty pink. And so you can't really see it. There's the diagram. No, I'm going down. Okay. So I want to look to see which way are these points going. Did I do something wrong here? 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's 1, 2, 3, 4. 1, 2. I'm going to go on 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Am I in the right spot? Yeah. Okay. All right. Because this should really be kind of tilted more. That's the problem. That guy needs to be more like this. It doesn't really go through there directly. Okay. So what's it going to look like when I graph it? I'm going to go this way, and I'm going on the outside. Doesn't look really good at all. 2, 1. So it's a positive 2, a negative 1, negative 1, positive 2. So go through that. We need to get rid of this. So we're going to drop a few points. Number 17, write the transformation equation for an absolute value when the function is shifted 3 units to the left, 2 units up, and has a compressed factor of 3/4. So I know that I'm going to have f of x is equal to, and I'm going to think a, an absolute value of x minus h plus h. That's my formula. So what's important stuff that I see? Compressed factor. Compressed factor of 3/4. Where's that going to go? A. 3/4. Anything else? Shifted 3 units to the left. So that's going to be shifted 3 units to the left. And so what is that going to be? absolute value of x, and then what do I put there? Left means negative, but I'm really going to do the opposite, which would be 3. And then what?
Plus 2.
And then it's 2 units up. That's my k, and that's plus 2. And so then I have f of x is equal to that. All right, dun 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 dun, the last one. So this one we're going to graph it. So we have to write it first, and then we have to graph it. So is this the same exact thing that we just did? Yeah. Okay. Good. So what do we have? For the answer, you guys graph it. We have f of x is equal to 3/4 absolute value of x plus 3, and then plus 2. So one thing you guys can do is go graph it on the graphing calculator and go take a look at what it looks like. I know that my vertex is going to be at a negative 3, 2, so I'm going to start there. I'm going to put some x and y coordinates on this thing. And so I know my vertex is going to be at negative 3, 1, 2, 3, positive 2. And so what happens is the stretch factor, that number is smaller, and so it gets a little bit wider. And so if you go graph it, you can grab some points. And I'm going to go here at 1, 5, 1, 1, 2, 3, 4, 5. That's a point that it's going to hit, and a negative 7, positive 5. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. And so you can go to the graphing calculator and you can go grab some of those points. And ladies and gentlemen, that concludes the review for Unit 3.